Okay, so we're going to look back and think about the difference between secant lines and tangent lines. So what's shown in orange here, that is the secant line, whereas the blue dotted line is the tangent line. So first let's talk about a secant line again. So we can see that through this parabola, the secant line is intersecting it twice, once at the green dot and again here at the blue dot. Um, if I were to move this blue or this green dot around, the secant line would change. So I can take this and move it, and I see that the secant line is changing based on which points it's going through. Now, the tangent line, which is the blue dotted line, it's just barely touching the parabola. It's not really going inside of the parabola. It's not going to hit the parabola in multiple places. Um, Right here, it's just going to hit it one time. So it like hits it and kind of bounces off. We can zoom in a little more to see it's getting closer to that point and then continuing out. Um, what we were looking at this for was because we were using the secant line to try and approximate a tangent line. So over here, we talked about how h is representing the distance between the 2 points. And by distance, we mean the difference in the x values or the horizontal distance between them. So if I make h the distance between these x values, if I make that smaller, we can see the green dot is therefore getting closer to the blue, but also the orange secant line is getting closer to the tangent line. And as I make this distance really, really small, the secant line looks like it's almost on top of the tangent line. When I move it all the way towards 0, then the secant line disappears because when the distance between those points is 0, there is no more secant line because by definition, a secant line goes through 2 points on a curve. If I move it just slightly, h to be just slightly larger, I can see my secant line again, but I can see that it's getting very, very close to that tangent. This was the buildup for the limit definition of the derivative, which basically just takes the slope between these 2 points and says, okay, but what is the slope going to be as the distance between these points approaches 0? That's why it's called a limit definition of the derivative, because we're looking at a limit as this distance is getting closer and closer to 0. Or another way to think of it is as the secant line is getting closer and closer to the tangent line. What is the slope of that line going to be?